There is a place in our galaxy where nothing delicate is supposed to last. Picture a region where the stars are packed together so tightly that if you lived on a planet there, your night sky would hold hundreds of thousands of stars bright enough to read by. There is no darkness. There is no quiet. The space between those stars is flooded with ultraviolet light and X-rays, and swept by stellar winds moving at hundreds of kilometers per second. And at the center of all of it sits an object 4 million times the mass of our sun, which does not shine, and which bends the paths of everything around it. This is a region where astronomers have long assumed that fragile things simply do not survive. And by fragile, I mean molecules. A water molecule is 3 atoms held together by a modest amount of energy. Hit it with a sufficiently energetic ultraviolet photon, and it comes apart. That process has a name, photodissociation, and it happens constantly, everywhere in the galaxy where radiation is strong and there is nothing to hide behind. Near the center of the Milky Way, the radiation is about as strong as it gets. So for decades, the assumption was straightforward. Dust gets destroyed there. Complex molecules get destroyed there. Whatever chemistry is happening in the calmer parts of the galaxy, the parts where planets get built, is not happening in the middle. And then, a team pointed the James Webb Space Telescope at a single dying star sitting just over half a light year from that black hole. They collected 25 minutes of data, and in the material around that star, they found water. The star is called EARS 3. The paper describing what Webb saw was published in the journal Astronomy and Astrophysics in August of 2026. Here is what I want you to stay for. First, for nearly 20 years, we had this star's basic chemistry backwards. And the correction is not a technicality. It completely changes what this star is manufacturing. Second, the water is surviving there for a specific reason, and once you understand the mechanism, it becomes one of the more elegant things in stellar astrophysics. And third, there is good evidence that this star is not from the galactic center at all. And that raises a question about the whole neighborhood. I am also going to tell you, near the end, exactly where the headline version of this story goes wrong. Because it does. Subscribe if you want more of these. Real papers, real data, and none of the exaggeration. First, some geography, because the scale of this place is hard to picture. Our sun sits in a fairly ordinary stretch of one of the Milky Way's spiral arms, roughly 26,000 light years from the center. Our nearest neighboring star is a little over 4 light years away. That is typical for where we live. Space around here is mostly empty. Now go inward. As you approach the center, the density of stars climbs steeply, and in the innermost region, it becomes extraordinary. In the volume that in our neighborhood contains one star, the galactic center contains millions. Astronomers call this the nuclear star cluster, and it wraps around the black hole at the middle like a swarm. That black hole is Sagittarius A star, 4 million times the mass of the Sun, compressed into a region smaller than the orbit of Mercury. It was photographed for the first time in 2022 by the Event Horizon Telescope, and it is the anchor that our entire solar system has been circling for 4.5 billion years. Sagittarius A star is a relatively quiet black hole as these things go. It is not blazing away like a quasar, but quiet is a relative term. It flares constantly and unpredictably, and the region around it is filled with massive young stars pouring out ultraviolet light and driving powerful winds. It is a hostile, crowded, energetic place, and there is a genuine, long-standing puzzle about it, which is worth knowing because it sets up everything else. Old, bloated red giant stars should be common in the galactic center. Stellar populations of that age produce them in large numbers, but when astronomers survey the inner region, they find far fewer of these stars than expected, particularly the brightest ones. This is known as the missing red giants problem, and it has been argued about for decades. Something in that environment seems to be stripping these stars, or disrupting them, or preventing us from seeing them properly. Which brings us to why we have been so limited in what we can observe there. Between us and the galactic center lie 26,000 light years of the galactic plane, thick with interstellar dust. That dust blocks visible light almost completely. If you look toward the constellation Sagittarius on a clear night, you are looking straight at the center of our galaxy, and you cannot see any of it. It is behind a wall. Infrared light passes through that wall much more easily. That is why every serious study of the galactic center is an infrared study. But there is a second problem. The particular band you need for studying dust and molecules, the mid-infrared, is largely absorbed by water vapor in our own atmosphere. Ground-based telescopes are working through a fog they cannot remove. Webb sits beyond that fog, and it carries an instrument called MIRI, the mid-infrared instrument, which is the only thing of its kind ever flown at this sensitivity. The team, led by Florian Piker at the University of Cologne, used it to do something surprisingly simple. They pointed it at one star and took a complete spectrum. Let me explain why that matters, because a spectrum is the whole story here. When light passes through gas and dust, particular molecules absorb particular wavelengths. Every compound has its own signature, a set of wavelengths it removes. So if you spread starlight out into its component colors and look carefully, you find dark gaps. Those gaps are a chemical inventory. You are reading the composition of the material without ever touching it. The catch is that you need continuous coverage. If your spectrum has holes in it, and you happen to have a hole exactly where a molecule's signature sits, you will miss it entirely and never know. For IRIS 3, nobody had ever managed a continuous mid-infrared spectrum. Every previous attempt had gaps, because of atmospheric absorption from the ground and instrument limits in space. Webb's MIRI delivered one running from about 5 microns out to nearly 28 microns, unbroken, from 25 minutes of observing time. It is the first complete mid-infrared spectrum of this object in the history of the field, and straight away, it settled an argument. IRIS 3 is the brightest object of its type in the galactic center, and it is peculiar in a specific way. Among the millions of stars in the nuclear cluster, it is essentially the only one wrapped in a large dusty envelope visible at these wavelengths. It stands out. It has been studied for half a century, and it has been reclassified several times because nobody could pin down what it was made of. In 2008, a study using interferometry suggested IRIS 3 was carbon-rich. That would mean the star was building carbon-based dust, essentially soot, and blowing it out into the galaxy. The new Webb spectrum showed 2 clear absorption features, one at about 9.7 microns, which comes from silicon and oxygen bonds stretching, another further out from those same bonds bending. Together they are unmistakable, and they are produced only by silicate dust, which requires oxygen. IRIS 3 is oxygen-rich. The carbon classification is wrong, and has been wrong for 18 years. Now, why does that matter enough to put in the hook of this video? Because carbon dust and silicate dust are 2 completely different raw materials with 2 completely different futures. Carbon dust is soot. Silicate dust is essentially microscopic sand. Silicates are the material that rocky planets are made of. The ground under your feet is silicate rock. It began as grains condensing in the outflow of a dying star, much like this one, drifting through space, gathering into a cloud, collapsing, and eventually clumping together into a world. So the correction is not bookkeeping. It changes what this star is contributing. It is not making soot in the middle of our galaxy. It is making the raw material for planets, which makes the second finding land much harder. In the material around IRIS 3, Webb detected clear signatures of water molecules. To understand why that is surprising, hold on to the photodissociation problem from earlier. Water in space, exposed to ultraviolet light, does not last. It is broken into hydrogen and oxygen. In an environment like the galactic center, saturated with ultraviolet from massive young stars, and with a black hole flaring nearby, the expectation was that any water would be destroyed almost as fast as it could form. So how is it there? The answer is that the star is protecting it, and the way it does that is the elegant part. IRIS 3 is in a stage of life called the asymptotic giant branch. It is a red giant near the end, about 6 times the mass of our sun, roughly 72 million years old, and shining with about 60,000 times the sun's luminosity. Stars in this phase become unstable in their outer layers and start shedding material at an enormous rate. The numbers for EARS 3 are difficult to hold in your head. It is losing roughly the mass of the Earth every 18 days, not over a year. Every 18 days, an entire planet's worth of material leaves this star and drifts outward at about 15 kilometers every second. It has been doing this long enough to build an envelope around itself roughly 10,000 times wider than the distance from the Earth to the Sun. And that envelope is the shield. The team modeled it using a radiation transport code called Hyperion, running roughly 100,000 variations before they found a configuration that matched what Webb actually saw. What came out was not a simple cloud. It was a structure organized into multiple concentric shells, each with its own temperature, density, and chemistry. Close to the star, where it is hottest, the dust is aluminium oxide. Further out, as the temperature falls, silicate grains take over. Across the whole structure, the temperature drops by around 1,000 degrees. Here is the mechanism. The dust in the outer shells absorbs incoming ultraviolet radiation. That is what dust does, and it is why dust makes distant objects look red. So the outer layers of the envelope take the damage, and the inner layers sit in shadow. Shielded from the ultraviolet, water molecules in there can form and persist. The star is manufacturing dust, and that dust is protecting the chemistry happening underneath it. It builds its own shelter out of its own material as it dies. There is one more detail from the modeling I find hard to stop thinking about. The envelope is not sitting still. EARS 3 is moving through the interstellar medium of the galactic center, and where the envelope meets that oncoming material, it forms a bow shock, the same shape as water pushed ahead of a ship's hull. This star is plowing through the middle of the galaxy, trailing a cocoon of dust and water behind it. Which brings me to the third thing I promised you. The modeling gives an age of around 72 million years. In stellar terms, that is young. Our sun is roughly 4.6 billion years old, so EARS 3 has existed for less than 2% of that. It is a 6 solar mass star burning through its life quickly, as massive stars do. But the analysis suggests something else. Based on its properties and motion, EARS 3 may not have formed where we now find it. It may have been born as far out as 16 light-years from the center and migrated inward over its lifetime. That is a meaningful claim, because it means the population of stars in the inner region is not necessarily a population that formed there. Things arrive, and if stars can drift in from outside, carrying their own chemistry with them, then some of what we see in the galactic center may be imported rather than made locally. It also connects to that missing red giants puzzle. If evolved stars in the center are being disrupted, and if the ones we do see are recent arrivals still carrying intact envelopes, that starts to look less like a contradiction and more like a process we can study. Now, the part I promised. Where the headline version of this goes wrong. You will see this reported as water found next to the Milky Way's black hole, and that framing gives you the wrong picture in 2 ways. The first is distance. Just over half a light year sounds like nothing when you are talking about a galaxy 100,000 light years across, but half a light year is still about 42,000 times the distance from the Earth to the Sun. It is thousands of times further out than the material actually orbiting close to Sagittarius A star. Close, in this context, means close compared to the galaxy. It does not mean the water is anywhere near the event horizon. The second is the nature of the thing itself. This is not a body of water. It is not an ocean or a comet or ice on a surface. It is water molecules detected as absorption features in the outflow of a dying star, mixed into gas and dust. The finding is about chemistry surviving, not about water existing as a place. And the science is more interesting than the headline anyway. The actual result is not that there is water near a black hole. It is that a star, in the most radiation-soaked environment in our galaxy, is still successfully manufacturing the raw ingredients of rocky planets and still shielding fragile molecules while it does it. The galactic center is not chemically sterile. It is running the same recycling process as everywhere else. Under conditions where we did not think that process could work. I should be equally clear about the limits. This is 1 star, 1 spectrum, 25 minutes of data. The shell structure is a model that fits the observations well, not a photograph. Nobody has resolved those concentric layers directly, and other configurations might fit too. which is exactly why the team tested 100,000 of them. And the distance we quote is a separation measured on the sky. The true three-dimensional distance from the black hole could be larger, because we cannot easily tell how far along our line of sight it sits. None of that undermines the detection. It just means this is the first data point of a new kind, not a settled conclusion. There is supporting work pointing the same way. The same research group previously studied a star cluster called EARS 13, roughly the same distance from the black hole, and found signatures of water ice there along with a surprising number of young stars, in a place where star formation was supposed to be suppressed. Two results, different objects, same uncomfortable conclusion. The galactic center keeps failing to be as hostile as we predicted. So, what did Webb actually find? A dying star, just over half a light year from the black hole at the center of our galaxy, shedding an Earth's worth of material every 18 days, wrapped in a layered cocoon of its own dust, with water surviving inside that cocoon because the star built the shield itself. And the reason we did not know this until now is almost embarrassingly simple. Nobody had ever managed to take a complete mid-infrared spectrum of it. Not because it is faint. EARS 3 is one of the brightest objects of its kind in the galactic center, and we have known about it for 50 years. We simply did not have an instrument that could see the whole picture at once. And so for half a century, we had gaps. And in those gaps, we had guesses. And one of those guesses about its basic chemistry was wrong the entire time. That is worth sitting with. This is the best studied region of the sky outside our own solar system. Enormous amounts of telescope time have been spent on it. And 25 minutes with the right instrument overturned a classification that had stood since 2008 and found molecules nobody expected to survive. So I want to know what you think the more surprising part is. That water can hold together half a light year from a supermassive black hole? Or that a star this well known could have its basic chemistry wrong for 18 years? In the most scrutinized patch of sky we have? Tell me in the comments. If you want more of these, real papers, real data, and the parts where scientists say plainly what they do not know yet, subscribe. Next time, we are going somewhere the light cannot escape from at all. Thanks for watching.